Machine learning and signal processing sounds intimidating, only until you realize it's simply teaching systems to recognize patterns the way humans already do. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why modern techniques exist, not just how algorithms are named. Most students think machine learning for signal processing is a completely new field that replaces classical methods like filtering or Fourier analysis. But in reality, it exists to solve a very practical problem: how to extract useful information from complex, noisy signals when traditional models are no longer sufficient. As signals become richer and environments more unpredictable, data-driven approaches become essential. To see this intuitively, think about how you recognize a familiar voice in a noisy room. You don't calculate frequencies or apply filters consciously. Your brain learns patterns over time and adapts to noise. Machine learning does the same for signals. Instead of relying only on predefined equations, ML models learn features directly from data, allowing systems to detect, classify, or predict signals more accurately. At a deeper level, machine learning complements classical signal processing rather than replacing it. Techniques like neural networks, support vector machines, and deep learning models build on features extracted from signals, whether in time, frequency, or time-frequency domains. This combination allows engineers to handle tasks like denoising, speech recognition, fault detection, and image analysis more effectively. On a larger scale, ML-based signal processing powers modern technologies such as medical imaging, wireless communication, radar systems, audio enhancement, and predictive maintenance. These systems operate in environments where signals are complex, nonlinear, and constantly changing, making adaptive learning-based methods indispensable. In real engineering practice, machine learning for signal processing is applied when designing intelligent sensors, improving communication reliability, analyzing biomedical signals, and automating decision-making from raw data. Engineers must understand both signal fundamentals and ML concepts to build systems that are accurate, robust, and scalable. Now that the intuition behind machine learning for signal processing is clear, the next step is to explore AI-driven communication and control systems where learning-based models operate in real time. And that's exactly what we'll cover next here at the Learning Studio.